Okay, welcome to another screen recording of producing the ball cam. What we're going to show you here, this is basically just a bracket. Okay, we're going to show you some Fusion360 techniques that we're using. This is basically just a bracket. It looks pretty much exactly what it is. It's actually going to be flipped on its side in use. These vertical sides are going to be uprights. These sides here are going to be actually vertical, upright. But we're cutting it out in Fusion360, and we're using basically 3 of the same tool paths, pretty much 3 of the same tool paths on either side, and then we're going to add a drilling pass at the end. First tool path is a 2D adaptive clearing, and then we're going to cut out the slot down here, and then we're just going to finish it off with a parallel facing. What we're going to show you with this video is a couple of things that Fusion360 does that seems to always result in loss of steps. It's been pretty consistent in terms of losing steps. We've seen it be pretty consistent in terms of losing steps. And I'm going to show you the 2 places in the code where you can almost always see a loss of steps. And I've seen it, it can be in any tool path. It has to do with the z-axis and how the z-axis moves on the ShopMaster. I'm not sure of the exact reasoning behind it, but I was able to find a pretty good solution, and you can see the pattern in the code. But first we're just going to look at the tool paths. Again, 2D adaptive slot clearing, or sorry, 2D adaptive clearing. We're going to go ahead and simulate this real quick, just so you can see it. We're going to run a simulation. We're going to add the stock, and now we'll go ahead and run the simulation. And you're going to see Fusion360 cutting it out. And in Fusion360, when you zoom out a little bit, it seems to speed the tool paths up a little bit. So we're going to let that go. Probably can increase the speed a little bit here. But you see we're running a screen recording, so the computer is running a little slower than normal. So we're just going to set the speed back to normal. Basically the CPU is lagging, so we're just going to let that be. Okay, so it's just going to do multiple depths of that same path that you just saw there, okay? Cutting out the top. 30 thousandths each pass. Then it's going to each pass. It's going to be basically doing a trochoidal milling, slot clearing type operation, and then the parallel pass is to finish things up. In the 2D adaptive, if you wanted to, in the adaptive tool paths, you can. There should be a setting for stock to leave. Okay, so in this case, if you were to set the radial stock to leave, that would leave a little bit on the edges here, on this face here, and the axial stock to leave would be, the axial stock to leave is going to leave a little bit extra stock right here on the bottom, on this bottom face, and then the radial will be right here on this face here. But we're not going to do that. You can, and then finish it up with your parallel, which is probably not a bad idea, actually. And we may do that when this is all said and done. The parallel path, when you want to go ahead and clean it up, when the adaptive clearing path is done, it may leave a little bit of uneven sort of jaggedness on this face, because as you see the tool, it's going around in a curved path and coming around here, and then kind of cutting this little lip out. So it's not doing like a parallel facing type. But when you're doing the parallel finishing, you probably have to use this feature here, the avoid/touch surfaces. This means either avoid a surface or touch a surface, okay? And basically what this green line is showing here is we are forcing that parallel pass to stay right on here on the square face, which is exactly where we want it. we're using the tool center on boundary here. And what will happen is on its last pass, it will clear out this face here, okay? This face here is what we want to clear out. Or we also want to tighten that up. And what I did with that is I set the step over. You want to make sure to set the step over. You probably want to be doing that with, not be doing a climb milling, but probably want to do it on a conventional. Both ways is probably okay. You may want to select climb or conventional. We don't have climb or conventional. So it's one way, other way, or both ways. But like in a case like this, the idea is right here on this last face, as the toolpath is coming finished, basically I want it to be on this last face here, be doing a conventional milling and really get the best, even if it's a very shallow depth of cut, go ahead and do the conventional milling to scoop out the metal and get the right cut. So it's going to go here, back, forth, back, and it's going to go as, you may just have to adjust the step over to make sure that on your last pass in a case like this. That's what I did. A couple of things here I'm going to show you in this parallel. Adaptives have the same thing that will affect your ShopMaster. I always lose steps right here if the horizontal and vertical lead in, lead out radii are set to something other than 0. If you set them to 0, it just does a perpendicular in and out movement, and it works fine. If you set it to a radius, the lead in, lead out will take sort of a J shape or kind of a corkscrew, very, very shallow, a very elongated helical ramp is what it does. And for whatever reason, the ShopMaster seems to lose steps on that. If you set it to something wide, like if you set a horizontal and vertical into something very wide, like 1/4 of an inch or something, the ShopMaster will probably be okay. If for whatever reason, trying to do a simultaneous movement on all 3 axes that's very tight, ShopMaster doesn't seem to work. So I just go ahead, set it to 0, and it seems to work fine. This transition type affects this right out here. You see on the parallel, the transition type is this green area right here. We set it to straight line, it works fine. You can set it to smooth, it'll put a little bit of a curve out here and smooth back. It's up to you. It works fine either way, I found. For whatever reason, I try as much as possible on the ShopMaster to not combine movement on more than one axis as possible, and certainly try not to combine movement on the X, Y, and Z axis. X and Y alone, and then Z separate is what I try to do. Okay, so now what we're going to do is we're going to go ahead and we're going to post-process this. We'll do the adaptive top clearing. The result's the same, but we're going to do the post-process. And you're going to see the other places where you lose code. Okay, so we put something in the name here, single post. We'll call it here, add that so we... Okay, we'll save that as a file. We're not going to use that one. And what we're doing is we're saving that file actually across a network drive onto the same machine, onto the Windows machine that's running the ShopMaster controller. And we're going to show you that in a second. Right here, in the beginning, this G43 command, for whatever reason, the ShopMaster always seems to lose steps there. Probably don't need it. Okay? You probably do not need it. And then this line here, where you see a G1 at the beginning of the line, some Z coordinate, and then a feed rate change, an F10. That basically is telling your Z-axis to get going and start doing its thing at a feed rate of 10. That always seems to cause loss of steps as well. So we'll show you how we fix that. We're going to go ahead and close this. This is being opened up in brackets. I don't need that. We'll probably maybe set that up in Fusion360 to use some other editor. But instead of brackets, what we're going to use is we're going to bring this guy over, and this is the VI editor. And we are going to open the we're going to open the file we just created. Okay, that's the file we just created. And remember, we saw this G43 line here. So that you can just change back to what it is. Get rid of the G43, let it just be what it is. That's a tool height compensation. It may only apply for a tool changer, I'm not sure. But you can just change it back to Z. Now, this line here, okay, there's going to be several of these, okay? So now we're going to use this expression here, right there, that expression there at the bottom of the screen, right there where the mouse is, okay, this one here. That is a search expression that allows us to find these search elements, see, right there, okay? Okay, now, this expression here at the bottom of the screen is a replace expression. And we're just going to run through this real quick to what this says. This caret means at the beginning of the line. It says if you find a G1 followed by a space character followed by a Z, and then any set of characters here, and then a capital letter F, and then any set of characters here, and then finally end of line, replace it with this string here, with this expression here. But this is what's called a regular expression down here. And probably the better way would, right here, this last part, we would, this dot star means any series of characters. I probably should tighten it down and say look for some kind of number followed by a period. But in any case, what this says is find an expression that matches, that looks like this here, and then substitute it first with a G4P3, then a new line, and then replace the original expression, follow it by a new line, and then another G4P3. So what happens is that this ampersand represents the original expression that you found, okay? So as soon as we hit this, boom, you see that right there, it added a G4P3 above and below the line, okay? So we're going to hit the U, means undo, and then we're going to redo that expression again. Look up here at line 22 and see what happens. See? And there's only one occurrence of that, it looks like, in the entire file. Otherwise, it would say that there was multiple occurrences of that. But it looks like in this particular one, it only did that one time and left it at that. Other toolpaths, you may see multiple occurrences of that. This is something that always causes a loss of steps. This guy right here, it's only a few thousandths, but here's how you know that it's causing you to lose steps, and this is very important. Assume for a second everything else on the machine is working just fine on the ShopMaster. It means there's no mechanical binding. And we're going to do another video on that, but again, very quickly, your belt tension is set correctly. Everything is lubricated and working smoothly. The set screws that connect the motor, the set screws on the motor couplings to your ball screws, they can work loose or they come loose when in shipping. You have to make sure they're all set correctly and have the right type of set screws. If the shaft couplings on the ball screws come loose, you'll be all over the place pulling your hair out. Assuming the machine is moving smoothly and can be jogged smoothly, a command like this, a G1 followed by a Z-axis move and a feed rate on the same line, seems to cause loss of steps. Look for it everywhere in your program. You may only lose about 3 thousandths or 5 thousandths, a few thousandths each time, but what will happen is each time you see that in your program, you'll lose like the same amount of steps. So the first time you run your program, if you lose 5 thousandths, the next time you run your program, your machine will be 10 thousandths off, and each and every time it'll be off by the same amount added, the same amount that you got, that your machine was off the first time gets added up each time. That's one of the ways you know you're losing steps, is it's very consistent. And if, for example, if it happens 5 times in the program and you only go run the program to the first time it happens, you'll see that it loses a certain amount of steps, and you run it to the same point the next time, it'll be the same each time. So loss of steps in G-code looks to be pretty consistent, and it's something you can compensate for. For whatever reason, the G4 P.P.3 means a 300 millisecond dwell is being inserted above and below this command. It seems to do the trick. Again, what you do in your G-code on your machine is up to you. This is for illustrative purposes only, but we've definitely found this to be the G43 up here, and the feed rate change on the same axis as a Z seems to always be a consistent problem. So we're going to save that file. Now that file is already on the machine that controls the ShopMaster, and that's this machine here, okay? We're actually using remote desktop to get to that machine over the network and recording the screen here. Now that machine is not on right now. When you're running the machine, you probably should be at the actual console of the machine. However, I will say that you should actually be at the actual console of the machine. However, if you're just running air passes, you can certainly sit at your desk and load this over the machine, run the machine, probably be okay. As long as nothing's spinning or turning or cutting, the worst that can happen is you'll probably hurt your machine but won't kill anybody. We're going to load that file now. Okay. And you see that basically load it right on the machine. Save it from Fusion360. We're using a Macintosh to run Fusion360. We save it across a network onto we save it on a remote drive on the Windows machine. Then we open up Mach 3 using remote desktop. And I think at some point we're going to go ahead and put a camera on that machine as well, bring that in across the network, so that we can actually, as we're running these things, we can actually run the Toolpath on the machine itself and you can watch it run. But at this point, if your machine was zeroed up, which it actually is in our case, we'd press cycle start. You'd get a tool change request and hit cycle start again, and you should be able to cut. So what you're doing is you're saving directly using a network drive, saving directly onto the machine that runs your Fusion360. You're saving directly from your desktop machine onto that machine. And then, as I said, you can use remote desktop to run it if you want to be dangerous. It's not recommended, but certainly there's no harm in saving it across the network. And by doing that search and replace that was shown in the editor, by using this search and replace string, okay, by using a search and replace in whatever editor you use, you're searching for a string that looks like this, and then just padding it top and bottom with a short dwell. If you do that, you should probably avoid losing steps. I've been doing that repeatedly now for a while. It does seem to work, and eventually I'm going to write a post processor that adds that automatically when saving something in Fusion360. So that's the Fusion360 ShopMaster lesson for today. Again, we were addressing the issue of losing steps in the Z-axis and G-code that causes you to lose steps. And eventually we're going to apply that to making these parts. This, as we said, is just a bracket. We're going to show the making of it later. But again, if you're losing steps in your ShopMaster Z-axis, number one, make sure everything mechanical is working fine. There's several mechanical components that have to come together. And then once that's all squared up and you can make sure your machine can jog, you should be able to jog your machine very consistently in the X, Y, and Z axis. You should have no troubles jogging your machine up, down, sideways in these axes. If it doesn't, you probably got a problem. These are the settings I use. On the X-axis, an acceleration of 0.5 seems to be fine. You can use more or less. There's some leeway there. I found that right now these settings seem to work okay, 23 and 0.5. These are jog speeds. These are rapid speeds. This is what you'll be jogging at. And that's part of the problem is the feed rate change. The G1 feed rate change ultimately tries to get the machine going at these jog speeds temporarily. And that may be the cause of the problem. Again, 23 and 0.5 works fine. for this particular piece. Other pieces you might want to set these differently. For sure I'm finding that these things are definitely toolpath dependent. On the Z, it's an upper limit. I can get acceleration as high as 0.9 on the Z-axis, and a speed of about 20. That's the upper limit. ShopMaster says use 0.1 on the Z-axis. That's unbearably slow for me. A speed of 10 on the Z-axis seems just about fine, at least in this toolpath. An acceleration about 0.6 is also about fine. Below that is okay. Below that is okay. Above a 0.9 or at about 0.9 acceleration, I'll start to get some Z-axis jamming just when jogging. The machine just won't hold it. So that's probably a more powerful motor needed. But you can see this graph here that tells you how long it takes to get up to your speed. So if the speed is 10 here, this says that it's going to take about 2,500 milliseconds, or just shy of, well, it's going to take about 2,800 milliseconds. It's going to take just shy of 0.3 of a second to go from 0 to 10 inches per minute. And in other words, that's your speed that it takes to get up to speed. So that you can use that as your guide. In other words, for the Z-axis to get up to speed, it's going to take about 0.3 seconds, which if you jog it out on your machine, you'll see about what works. So those are ways to figure this out. ShopMaster has its own recommended settings. All I can say to that is, start with your recommended settings, and if you're going to adjust it, just be careful what you do. Adjusting up and down. Make sure that before any G-code or motor configuration settings can be used, the machine has to be mechanically fine. You really have to make sure nothing's jamming, no ball screws are catching or jamming on anything. The belt train on the Z-axis is working right, and as I said, the motor couplings, those set screws come loose. Make sure they're tightened down and you got them locked tight, because they will work loose and they will drive you crazy. And as I said, anything else mechanical you can think of. Once that's done, you should be able to jog the machine reliably, and then as you go up and down on your jog speeds and accelerations, you'll sort of find out what the upper limit is for jog speeds. And those are definitely going to be the upper limit in your program for anything. And what's going to happen is those feed rate changes we show you basically transition from your cutting speed to your jog speed. So another way to help yourself with that G-code problem is to save these settings as multiple profiles in your Mach 3. You can save a whole bunch of different profiles, and it's a good idea to probably do that. You may have a profile for steel, you may have a profile for aluminum, you may have a profile for adaptive clearing, you may have a profile for slotting. You may find that these motor settings, you want to tune them per your toolpath. That's just the way it goes. Another possibility, as I said, is if you know your cutting rates are going to be low, you can save yourself a favor by setting these speeds very close to your cutting. Once you establish your cutting rate speeds for a particular project, go ahead and set these speeds at the upper limit of whatever your fastest cutting speeds are. Adjust the acceleration to a way that makes sense to where your toolpath runs smoothly, and then save that as a profile. That's another way to go about it. And the way I describe it is, I'll probably say this many times, when it's all said and done, if the spindle's not running and you're listening to the sound of the stepper motors, when your machine is working right, it should sound like a happy robot. It should sound like a nice, happy robot. If it sounds like an angry robot, you probably need to fix something. All right, thanks for watching today. That's the ShopMaster video from Ballcam on how to avoid losing steps in your Z-axis on your ShopMaster MillTurn 2017. Thanks for tuning in.